Hello, everyone. So, there's a couple problems that we're going to work on today. And for those that are curious that are taking the course, this is POD 10. So, the problems that we're going to be focusing are 2A, which is dealing with colligative properties specifically. And then the second problem will be involving concentration units, which is problem 3 here. So, I have already worked out the solutions to these, so I'm going to go over these with you, but I'm going to try to do it in a way to where it's almost as if we're doing it again. So what I'm going to do is pull this up, and we're going to work on problem 3 first. So in this particular problem, we want to try to understand what information is given to us, and then the problem that's asking. So you always want to just make sure you double check what's given and how you might be able to take that information and use it to solve for the problems that are presented to us. So in this particular problem, we have a solution of sulfuric acid containing 571.6 grams per liter of solution and with a density of 1.329 grams per milliliter. So first of all, we know that in this particular case, the solute will be H2SO4. We're assuming that it's in water, but it's not important at this moment. So there's three pieces of information they give us. They give you the mass of sulfuric acid. They tell you that it's per liter of solution, and they also give you the density of the solution. So in part A, it says calculate the mass percent of the solution. And so what we're going to be doing, we're going to be looking at the mass percent of this sulfuric acid here. And so the first thing is that the nice thing is they give you the mass of H2SO4. But what we need to do is we need to figure out what the mass of the total solution would be. So what we'll do is we'll use the fact that we have a liter solution. We know the density is 1.329 grams per milliliter. Now the units need to work out, so we'll convert our milliliters into liters for the density. So what you can see here is we've taken 1 liter, multiply it by the density, and then we convert that unit of milliliters into liters. And so what ends up happening, the units cancel out. So your liters cancel, and then your milliliters cancel. If you have this set up correctly, you will end up with grams in the end, and that's what you want to end up with here. So because our ultimate goal is to figure out the mass percent of the solution. So the mass percent of the solution would be, so we need our sulfuric acid on top because that's a solute, and then the total mass of the solution will go on the bottom. So you get a ratio. We'll multiply that ratio by 100, and what we end up with is 43.0% H2SO4. Now, significant figures, if we want to go off sig figs, we would need to have 4 sig figs for our final answer. So that would be 43.00%. Now, if you're asking, well, how do you know how many sig figs you're supposed to have? I look at the information that's given to us here, and both numbers that are given to us have 4 significant figures. So that's why your answer should be 4 sig figs. So the way it's written out here, this is 3 sig figs, and this one is 4 sig figs because the 2 zeros on the end count along with the 4 and the 3. Part B to ask us to calculate the molality of the solution. So molality is moles of solute per kilograms of solvent. In this particular example, water is our solvent. So the first thing I'm going to do is take the mass of sulfuric acid, and we need to convert that into moles by dividing by the molar mass. So on the right hand side, you see how I figured out the molar mass, and then I divided it in by 98, and I get 5.833 moles. So the second thing we got to figure out is the mass of the water. Now what we do know is we know the mass of the solution we just calculated from up here. We know the amount of sulfuric acid that's in that solution, so we subtract the two from each other, and we end up with the grams of water, which we convert that into kilograms. So to calculate the molality, what we do is we take the moles of sulfuric acid divided by the kilograms of water, and you end up with 7.701 molality for this particular solution. Now the last part to this question would be calculate the molarity of the solution. So molarity is moles of solute per liter of solution. We already have the moles of sulfuric acid here because we just calculated that in part B. And they also tell us that we have per liter of solution. That was the information given to us in the beginning here. So all we do is just divide them out, which if you divide by 1, you end up with the same answer. So the molarity would be 5.833 mole of H2SO4. So this is just a problem involving concentrations and units. So that's all concentrations are, just a reflection of the varying units that you have. So unit analysis is important here. Now problem 2 is involving glycerol, and again this is a colligative property problem because we're dealing with freezing point depression, and if you read the question you'll see what I'm talking about. So it says glycerol is a non-volatile molecular liquid that is very soluble in water. A solution is made by dissolving 75.0 grams of glycerol in 350.0 grams of water. What is the freezing point of this solution? So they also give you the information of delta T is equal to I KFM, whereas your Van Hoff factor, Kf is the freezing point constant, and M is your molality. So again, we just worked a problem involving molality. We know molality is moles of solute per kilograms of solvent. So what we need to do first is figure out the moles of the glycerol. So again, you'll go ahead and figure out the molar mass of this. Take the 75 and divide it by that molar mass, and you will end up with 0.815 moles. Now the molar mass of that compound is 92 grams per mole. The second thing is we'll take the grams of water and we need to convert that into kilograms. Simply just move the decimal place to the left 3 times, and we end up with 0.3500 kilograms. So we have 3 sig figs and 4 sig figs. When we go through the calculation here, we'll end up with 2.33 molal, and that would be representative of the significant figures also. Now sometimes you can just carry out the number and do your sig figs in the end. We're not going to do that here. We're going to carry out sig figs here. So we'll take this molality, plug it into the equation to solve for delta T. They give you the freezing point constant, which is 1.86. Now the Van Hoff factor is representative of how many ions are present. Well, since glycerol itself is an organic compound, it's not an ionic compound, it's covalent, and covalent compounds are going to be 1 for the Van Hoff factor. So we go through the calculations, we end up with delta T is 4.33. Now that's not the final answer. What we need to do is take the fact that we're dealing with freezing point depression, and glycerol is going to reduce. It's called freezing point depression in quotations there. Depression means it's going to go down. So we're going to subtract the 4.33 from 0 because that's the freezing point of water. You can look that up in the data table if you need to. And that you end up with negative 4.33 degrees Celsius. So the combination of these two questions, you need to understand the concentration units before you're able to go into the colligative properties. So that's why I wanted to present these two problems to you in the order that I presented them. So hope this makes sense. If you have any questions, you know what to do. Thanks.